Hi everyone. In this video, we are going to discuss this example. Actually, we are discussing right now reducible to exact. In previous videos, we have seen what is exact differential equation. If it is exact, how to solve. But see, if it is non-exact, how we can convert it into exact differential equation and then we can solve, right? So let us start with this example. Okay. I will revise few things first. If you have differential equation in this format, m dx plus n dy is equal to 0, m and n are functions of x and y. When we say it is exact, if dabba m by dabba y is equal to dabba n by dabba x, then we say it is exact differential equation. So let us check first the given differential equation is exact or not. So what is m? M means multiple of dx. So here the multiple of dx is this bracket. After that, I will write n, which is multiple of dy. So the multiple of dy is this term. But see the minus sign it has, so I should consider minus 2xy. So now we have to check whether these two partial derivatives are same or not. Let us check. So dabba m by dabba y, derivative of m with respect to y. So x square plus y square plus 1. You can easily see there are three terms separated by addition. So I will take separate derivatives. Derivative of x square, derivative of y square, and derivative of 1. We are differentiating with respect to y and we have a function of x. So when you differentiate with respect to y, x and functions of x are constants. Derivative will be 0. Derivative of y square, so we are familiar with this formula, let me tell you. So that derivative of x raised to n is n x raised to n minus 1. So when we take derivative of such term, whatever the power, we write it first and we reduce the power by 1. So here the power is 2, so we can write 2. We reduce it by 1, 2y is y raised to 1. Derivative of 1, 0, since 1 is constant. So answer is 2y. Now I should work on the second partial derivatives also, right? And we have to check whether both of them are same or not. So now dabba n by dabba x. Okay, so what is my n? Minus 2xy. Minus 2xy. So what I do, whatever the constants we have, we always take outside first. So minus 2 is constant, will come outside. Y is also constant because we are differentiating with respect to x, so y will come outside, and inside the derivative we have x only. So derivative of x with respect to x is 1. It means minus 2y into 1, so it is minus 2y. Getting? So here we get the derivative 2y, here we get the derivative minus 2y. That means these two are not equal. It means the given differential equation is non-exact. So let me clearly mention here. Okay. Let us use this space. Therefore, dabba m by dabba y is not equal to dabba n by dabba x. Therefore, given differential equation is non-exact. That's it. The given differential equation is non-exact. So now we have to convert it into exact differential equation by using integrating factor. So now the question is how to find integrating factor. Actually in previous video we have already seen what are the 4 different methods, 4 different rules of finding integrating factor. Let us revise. The first thing is if dabba m by dabba y minus dabba n by dabba x divided by n, if function of x, then the integrating factor is e raised to integration f of x dx. Okay. So what we do, we find the value of this fraction. If we get just function of x only, then we go for the first rule. The second rule is dabba n by dabba x minus dabba m by dabba y. Simply we interchange their roles. Okay. N replaced by m. Here we get a function of y. Here we get function of x. In rule number 2, we get function of y. In that case, integrating factor e raised to integration f of y dy. So these two rules we have. The third rule, the differential equation must be in this form: y f1 of xy dx x f2 of xy dy. And the last rule, okay, I'm not writing the third rule in details, okay, simply I mentioned the condition. The function must be homogeneous, that means degree must be same, getting? The function must be homogeneous. So generally what we do, we start with the last rule. It's quite easy to check whether it is applicable or not. Otherwise we go for the third rule. It is also quite simple to check whether it is applicable or not. If both rules fails, then only we go for first and second rule, right? Homogeneous, okay, let us check homogeneous. Power 2, 1 is there, which is constant, so power 0. Homogeneous, that means degree of each term must be same. But here we are getting degree 2, degree 1, sorry, degree 0. So degree is not same. It means the fourth rule is not applicable. Okay. Third rule. In case of third rule, we should have xy everywhere. Xy, getting? Here there is no any y. Here there is no any x. Here xy is not there. Getting? So that's why the rule number 3 is also not applicable. So then there are only two chances, either the rule 1 is applicable or rule 2 is applicable. Let us check. So I will go for rule number 1 first. Okay, so consider the rule number 1 is deba m by deba y minus deba n by deba x divided by n. I will find its value and check. I will check whether it is function of x or not. What is deba m by deba y? 2y minus deba n by deba x minus 2y n, yes, minus 2xy. Okay, I will solve it here. 2y minus minus plus minus 2xy. Their sum will be 4y upon minus 2xy. Okay, tell me what can we cancel? Y will get cancelled, right? And 2 1s are 2, 2 2s are 4. So at numerator we get 2. In denominator x is there, minus x is there, that means minus 2xy. So we get just function of x only. Yes. So rule number 1 is applicable. Getting? So we should have function of x only. There should not be any y. So all y's are removed and we get a function of x only. That means definitely rule number 1 is applicable. So I will continue. So in that case, what is integrating factor? So integrating factor is e raised to integration f of x dx. It means e raised to integration. Our f of x is minus 2 by x dx. So in powers of e, we have to solve that integration. Okay. Okay. So it is not required. Let me remove this part. Okay. And let us use this space to solve remaining part of this problem. Okay. So e raised to minus 2 is constant, will come outside. So 1 by x. What is integration of 1 by x? Anyone knows? Minus 2. Integration of 1 by x is log x. Since derivative of log x is 1 by x, integration of log x is integration of 1 by x is log x. So there is one property of log, n log a. Log a raised to n. When you have any multiple of log, you can shift as a power of a. Getting? So the same rule I can use here. So e raised to, so minus 2 we can write as a power of x. So e raised to log x raised to minus 2. So we will get one benefit of it. Log and e will get cancelled. It means x raised to minus 2. To change its sign, I will shift a denominator, then it will be x raised to 2 only. So this is our integrating factor. It means this integrating factor will create a magic. If you multiply it, okay, if you multiply the given differential equation by integrating factor, this non-exact differential equation will be converted into exact differential equation. So let me clearly mention. Okay, so let us call it as equation number 1. Multiplying 1 by 1 upon x square. Okay, so I'm going to multiply the given differential equation by this 1 upon x square. See, this x square is in denominator. So when you multiply, obviously it will go in denominator. Getting? So what will you get here? X square plus y square plus 1 divided by x square dx minus, here also it will go in denominator, 2xy upon x square dy is equal to 0. It is better to divide separately. It means x square by x square plus y square by x square, or simply y square plus 1 by x square dx. X will get cancelled, minus 2y upon x dy is equal to 0. So we multiplied given differential equation by this integrating factor. That means definitely it is converted into exact. If you want, you can cross check. How to cross check? Del by m by del by y is equal to del by n by del by x. This condition will be definitely satisfied here. So let me mention, it is an exact differential equations. It is converted into exact. Okay, so here also x square we can cancel, huh? Oh, yeah. So what is my m? Multiple of dx. This is my m. Getting? This is my m, new m, and this is my new n. So this is exact differential equation. What is my new m? X square upon x square we can cancel. So 1 plus y square plus 1 by x square. And what is my n? It is minus 2y by x. So it is exact. So that means we can follow the same method which we use for exact to find the solution of exact. We add two integrations. Okay, so let me tell you first and then we will move further. Then solution of this exact differential equation is, the solution is integration m treating y constant dx plus integration terms in n free from x dy is equal to c. This is a fixed formula to find solution of any exact differential equation. So I will follow the same. Here simply we have to add two integrations. Getting? So what will I do? I will solve these two integrations separately and then we will add. So just make a screenshot of it, then we will move further. Okay. So I will solve the first differential, first integration. Okay. So what is the first integration? Consider integration m treating y constant, right, dx. So what is our m? This is our m. So let us write 1 plus y square plus 1 by x square dx. You can see there is an addition, so we can take separate integration. Integration 1 dx plus integration y square plus 1 by x square dx. 1 dx, that means integration of dx, which is x. Integration of x dx is x. Here what will I do? Whatever the constants, we take them outside. So the constant is y square plus 1. Entire bracket is constant. Since y is constant, we have already mentioned. So inside the integration, we have 1 by x square dx. So this is equal to x plus y square plus 1. What will I do? I will shift this term to the numerator. It means x raised to minus 2 dx. X raised to minus 2. It means this formula is applicable. Which formula? Integration of x raised to n, x raised to n plus 1 upon n plus 1. Whatever the power we have, we add 1. I will do the same. X plus y square plus 1. What is the power? Minus 2. I will add 1. Minus 2 plus 1, which is minus 1. And the same number in denominator, minus 1. That's it. X minus plus minus y square plus 1 as it is, x raised to minus 1. Getting? So if I shift to denominator, it is 1 by x. So let me mention the final answer. Okay, just a minute, huh? So it will be x minus y square plus 1. Getting? I am simply taking the product y square plus 1 into 1, y square plus 1, x is in denominator. That's it. So we got the value of first integration. So let us move further. We will try to find the value of second integration. Now, what is the second integration? terms in n free from x dy. So we find just terms of n which are free from x. There should not be any x. How many terms are there in n? Only one term is there, minus 2y upon x. There is x? Yes, there is x. That means we cannot take that term. So that's why I should write 0 directly. So therefore the solution is, so this is the solution. Value of first integration we have got x minus y square plus 1 by x. Getting? And value of second integration is 0. So no need to add, is equal to c. This is required answer. Okay, so in this way we solved this non-exact differential equation. Initially it was non-exact. By multiplying integrating factor we converted into exact and we found out its answer. Okay, so make a screenshot of it, then we will stop. Thank you. See you in next video.